Boyle's law is the inverse relationship between volume and pressure. When pressure increases, volume decreases, and when volume increases, pressure decreases. This creates the equation P1 times V1 equals P2 times V2, where P1 and V1 are the initial pressure and volume, and P2 and V2 are the final pressure and volume. For this relationship to work, temperature and number of moles must remain constant. This relationship is valid because pressure is caused by collisions, and when the same number of molecules are placed in a smaller volume, more collisions will occur. And when the same number of molecules are placed in a larger volume, less collisions will occur. Let's look at an example problem to see how to use this relationship. A balloon contains 7.2 liters of helium. The pressure in the balloon is reduced to 2 atmospheres, and the balloon expands to occupy a volume of 25.1 liters. What was the original pressure exerted on the balloon? The first thing you must do is identify what parts of P1V1 equals P2V2 are given to us and which we are solving for. We can see that the problem asks for original pressure, so we know our variable must be P1. We also know that initial volume is equal to 7.2 liters, final pressure equals 2 atmospheres, and the final volume is equal to 25.1 liters. By substituting these values into the equation, we get P1 times 7.2 liters equals 2 atmospheres times 25.1 liters. First, multiply 2 atmospheres times 25.1 liters, which is equal to 50.2 atmospheres times liters. Next, divide 7.2 liters from both sides of the equation. Because the units L will cancel out, we find that 50.2 atmospheres times liters divided by 7.2 liters is equal to 6.97 atmospheres, which is equal to P1, our initial pressure. Our final answer, however, is 7 atmospheres because significant figures go out to the first decimal place as dictated by the volume 7.2 liters. Now let's look at another problem. A sample of neon occupies a container at a volume of 461 milliliters at STP. The pressure in the container is reduced to 93.3 kilopascals. What will the final volume of the container be? The first thing we'll do is set up the equation. Plug the values from the problem into the right place in the equation. At STP, pressure is 101.325 kilopascals. So P1 equals 101.325 kilopascals. V1 equals 461 milliliters. P2 equals 93.3 kilopascals. And V2 is what we're solving for. Now we're ready to solve. Multiply P1 and V1 together, which equals 46,710 kilopascals times milliliters. Now divide both sides by P2 to isolate the V2 variable. 46,710 kilopascals times milliliters divided by 93.3 kilopascals equals 500.652 milliliters, which is our final volume. But don't forget significant figures. For multiplication, the least number of sig figs in any number of the problem determines the number of sig figs in the answer. In our case, it was 3. 500.652 milliliters is now 501 milliliters. The P1V1 equals P2V2 equation can be used to solve for pressure and volume regardless of what the units are, like liters, milliliters, atmospheres, kilopascals, etc., as long as the units on one side of the equation are the same as the units on the other side of the equation.